Welcome to the video session of 43 of network security. In this session, we are going to discuss about description of MD hash family. So, we'll recap the old one, cryptographic hash functions, where the types of hash algorithms. And in this learning objective is the main objective of this session is to get familiar with the MD hash family. So the outcome of this session is able to describe MD hash algorithm and able to understand the design principles of MD algorithm. And to understand the MD hash family, we need to prerequisite knowledge of cryptography, applications of XOR operations, and now we will see how the MD hash family is going to be established. The MD hash family comprises of hash functions MD2, MD4, MD5, and MD6. It was adopted as Internet Standard RFC 1321 and it is a 128-bit hash function. All MD functions share a common structure of the compression function. The compression function consists of two major parts. One is message compression and second one is consecutive evaluation. The compression function will perform in 3 to 5 rounds. The input chaining variables are added to the output. The hash function of MD family are iterated hash functions and follow the MD design principles. All these functions share a common structure of the compression function, which is shown in this figure. The compression function consists of two major parts, which are the message expansion and consecutive evaluation of a number of similar operations called steps. These steps are usually grouped together into 3 to 5 rounds. After the last step of the compression function, the input chaining variables are added to the output, which complicates the inversion of the compression function. The message expansion ensures that each message block is used more than once during one iteration of the compression function. Message expansion function consists of the following basic operations, that is a bitwise boolean function, integer addition modulo 2, bit shifts and rotations. There are two different types of message expansions, the round wise permutation and the recursive message expansion. And in roundwise permutation, the message words are not changed but rather used in different order in each round. The recursive message expansion was designed to increase the diffusion of the message words. Nearly all inputs of each step depend on all message words. Thus, a small change in one message word immediately affects many steps. In each step of compression function, a number of registers 4 to 8 depending on the algorithm are updated by compression one word of the expanded message. The operations of one step are very similar in every specific hash function and consist of the following basic operations: bitwise boolean function, integer addition modulo, bit shifts and rotations. These operations have been chosen because they can be efficiently evaluated and it is assumed that their combination is cryptographically strong. Each step of the compression function differs only in the use of different parameters or a different Boolean function. The hash function of the MD family use the following Boolean function in their step. Bitwise Boolean functions are XOR x, y, z equal to XOR of y, YR of z, and MAJ XYZ equal to XY product of XY XR and product of XZ XR and product of YZ. If x, y, z equal to product of XY XOR of XZ and XOR of Z. Multiple choice questions we can ask. Compression function in MD algorithm consists of one is message expansion, consecutive evaluation, both A and B, and now that answer will be both A and B. That Boolean function is MD family uses the following Boolean functions in their steps, and the references of this is Frozen McGraw-Hill networking series.